That never happens.
It's all good. I can do it again.
All right. Well, I think we are live now. So thank you everyone so much for your patience. We had a little bit of a tech glitch on this side. We thought we were live. We started without you. So we're going to start over. Everybody, I'm Amy Oliver from the Fred Lawrence Whipple Observatory, and thank you so much for joining us tonight. And thank you again for your patience. I'm really excited you're here tonight because we are welcoming my friend and our community partner, Derek Demeter from the Emil Buehler Planetarium at the Seminole State College in Florida. And now I'm actually glad we got to redo this, and I'm going to announce that before I tripped over that name a few times, so it was kind of a joke for us. I'm not going to spend a lot of time introducing Derek for you tonight, especially because we had this tech glitch and we're starting a little bit late. But most of you here tonight already know Derek. You have met him through previous star parties with us before, and he has a really cool presentation for us tonight about misconceptions in science, and he's going to be talking a lot about Pluto. So without further ado, I would like to introduce my friend Derek Demeter from the Emil Buehler Planetarium at Seminole State College in Florida.
All right, thank you, Amy, and thank you for having me on your star parties. And I'm really excited about being able to share and present a program tonight. And I want to talk a bit about this whole thing of Pluto. So as a planetarium director and somebody who's out in the public a lot, teaching the public, teaching school children, teaching college students, pretty much all over the place, one of the questions that I generally get a lot of is, why isn't Pluto a planet anymore? Where did Pluto go? And that's kind of one of the things that I want to talk about tonight. And we're actually going to talk about this through some really funny things, through nerdy t-shirts. So what I'm going to do now is I'm going to go ahead and share my screen here. And we're going to talk about this thing. The title of the program is called Rest in Peace, Pluto. Now, as I said, we're gonna talk about these science misconceptions and things like that, and getting kind of in the nitty gritty about this whole Pluto thing. And we're gonna talk about a few other funny things too later on. And when, of course, you look at a shirt like this, you think of, okay, rest in peace. That usually means something has died or deceased or gone away, right? And you can even see dates, 1930 to 2006. 1930, of course, is when Clyde Tombaugh discovered Pluto using the Pluto Discovery Telescope in Flagstaff, Arizona at the Lowell Observatory, right? Now, of course, we'll talk about this 2006 part later, why that's in there. But in reality, did Pluto get did it blow up? Did the Death Star reach our solar system to destroy Pluto? Well, no, it didn't. But, when I see a t-shirt like this, I can't help to have a little bit of a cringe because of the fact that, unfortunately, it's not really telling us the true story. And I figured, I did this program last year or so, and I thought this would be a fun program to revisit and share with all of you this evening. So where did this whole thing about Pluto not being a planet thing come from? Well, first thing first, you've probably seen things. This is actually coming from another t-shirt as well. The family portrait, if you will, of the solar system. Here we have the sun. And by the way, the planets are not to scale, obviously. But there's little poor Pluto. Look at little poor Pluto. Look how sad he is. Of course, when it comes to a portrait of the solar system, we're missing comets, we're missing asteroids, we're missing the other dwarf planets that are out there, the trans-Newtonian objects. I mean, boy, this whole thing would get filled with a lot of amazing stuff in our solar system. So usually when people learn about the solar system, they learn about the planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and of course, Pluto. But we also forget the fact that there are other things in our solar system than just those objects. So again, this is another one of those nerdy t-shirts. There a lot of people iron on them and stuff like that. And as you can see here, little Pluto is sad that he's not allowed in the picture, which I think is ridiculous. I mean, the fact that Pluto still is an amazing, wonderful object in our solar system. And I'm going to show you some of the cool things we recently discovered about Pluto through the New Horizons mission and things like that. So where did this whole Pluto thing start? Well, I don't like to really blame people, but when the person himself actually likes to be called the Pluto killer and actually gets excited about being called that, well, Mike Brown really was the one that kind of started this whole thing with figuring out what Pluto really was in our solar system. And in reality, he and his team at the California Institute of Technology actually did a lot of amazing discoveries when it comes to things beyond Neptune's orbit. Discovered several trans-Newtonian objects, discovered even a new object called Eris, which kind of sparked this whole debate on whether or not Pluto is a planet or not, and other objects that are even further out beyond that. So this is kind of where it all started, and this is where it all kind of began. And again, you know, as I said, I usually don't like to bring up certain individuals, but again, I think it's kind of funny that his actual Twitter handle is Pluto Killer. So again, and he had a background here of the Death Star blowing up Pluto. So, you know, in reality, this is kind of where it sparked, and it sparked around 2006, hence where the T-shirt has the final date on there. Another nerdy T-shirt that I see a lot, and this is actually, I see this a lot in other aspects besides Pluto, but things like Dear NASA, your mom thought I was big enough, love Pluto. I see a lot of people blame NASA for a lot of things about, you know, space, or Dear NASA, thank you for ruining my childhood dreams of Pluto being a planet. In reality, NASA had nothing to do with it. NASA's become kind of the official scapegoat, or just the target of all the things that are bad about space. But in reality, NASA is not the only space organization, astronomy, whatever you want to call it, in the world. There's tons and tons and tons of organizations, and the one that actually can officially designate something in the universe as, say, a planet is actually the International Astronomical Union, the IAU. This organization is the one that actually officially can designate an object as a planet, as a star. You probably have heard of those things where you can name stars after your family member or whatever. In reality, only the International Astronomical Union can officially designate an object in the sky. So in this case, Pluto this is where the debate started with Pluto. Pluto, after a committee got together, essentially the astronomical community decided to recategorize, and I like to use that word, recategorize Pluto as a dwarf planet. So we didn't destroy it. We didn't get rid of it. We didn't annihilate it. We didn't do anything bad. All we did was put Pluto in a new category of objects in our solar system. One of the things that I like to give you an example of, actually, I did a whole round of library visits several years ago. We had there was the library summer reading program, was all about space. And so I went to, you know, hundreds of libraries. It was insane. That summer was ridiculous. And one of the things I'd like to put an analogy is that what if you're a librarian and you discover a brand new book? And this book has contents of fiction and nonfiction and maybe mystery and fantasy. It's all over the place. And it seems like it's the only book of that kind. Well, maybe at first you might put it in the regular fiction category. But then as you discover new objects and new books that share those same characteristics, you start to go, hey, maybe I could take these books that all share the same characteristics and create a new category in the library. And that's pretty much kind of what we did with Pluto. What we did is we discovered these objects like Eris, there's Makemake, there's Haumea. There's all these tiny little worlds beyond Pluto that share much more closer similarities to Pluto than the other planets in our solar system. So, for example, let me go into the three definitions that really classify a planet. And so a planet must be round. Pluto fits that category. It must orbit the sun. Well, it does. And it has to clear its path of pretty much most of the space junk in its orbit. Well, Pluto, Eris, Haumea, Makemake, these worlds haven't really cleared their paths of this space junk. So that's kind of what recategorizes Pluto as that. Now, there has been some debate on kind of putting Pluto back in the list and all that. But either way, it does, regardless of if you consider Pluto not a planet or a planet and you want to hold on to that thing forever and ever and ever, you don't want to give it up, the point of it is that Pluto, regardless of what its name is still an amazing place. And we have discovered some really cool stuff about Pluto. Now, this is the New Horizons spacecraft. It's about the size of a grand piano. It took over 10 years to make it to Pluto. And when it did back in 2015, New Horizons flew past Pluto, and for the first time ever, we've been able to get really high definition images of Pluto. Before that, the best images of Pluto we were ever able to acquire was from the Hubble Space Telescope, and it didn't really give us a lot of detail, mostly darker and brighter regions, and giving us kind of a clue of possibly there could be ice and there could be other things, but nothing in terms of really good clarity. But New Horizons changed the game when it came to actually seeing Pluto. And this is the Pluto that New Horizons gave us. Now, this is a false color image of Pluto, but it still gives you just this amazing world that is alive. It's geologically active. There's actually movements. There's uplift, just like you'd see on Earth. And this thing is this world has some really cool features. One of them is the Sputnik Planum, or the Tomball Regio, which Sputnik Planitia, actually. Sputnik Planitia is this huge, giant, frozen nitrogen glacier sheet of ice that's actually on top of a layer of water ice, and is actually undergoing convection. So what's happening is that the layers below are actually churning around and are actually causing the ice to move and change and form these really crazy shapes along the surface, these troughs, these large valleys and mountains and all kinds of stuff. This is an amazing little world. And the average temperature of this ice is very, very cold. Actually, the surface temperature of Pluto is about minus 350 or so degrees, give or take. It's a very, very cold place. But not only do we have these large frozen, surfaces like we see here, we also have mountain ranges. This is a picture taken in the Norgay Mountains, named after the Sherpa Norgay that actually followed Hillary on the first expedition to Mount Everest. These are uplifted by the fact that the ice sheet of the Planitia is actually moving around. It's moving material up, just like you would see on Earth's surface, where you have mountains that are actually being uplifted. These mountains you might think are like Earth's mountains, made up of granite and gneiss and limestone and all. These are actually made up of water ice, mostly water ice and other ice material. So you have these mountains that some of them can be as tall as 20,000 feet. All right, that's like the size. That's like as tall as Denali in Alaska. Of just solid ice. You're talking about a world that is incredible. But one of my favorite regions of Pluto is the Cthulhu region of Pluto. There is this material called thulin, which is this tar-like material that has actually formed from cosmic rays and solar radiation from methane and nitrogen gas. And it creates this tar-like material that is organic in nature. And so, believe it or not, the things that are essentially the byproducts of, are the, not byproducts, but the ingredients for life are actually found in this tar-like material. So could Pluto actually have life? Well, I don't know. Nobody knows. And you know what? But at least we have found evidence of this tar-like material, which we actually find on a lot of other far away worlds. We find this on Iapetus, on several other moons of Saturn and Uranus and Neptune. And Ultima Thule, which is a small little object that we just flew past, and with New Horizons also contains this material. So we find this stuff all over the outer solar system. So who knows? What if some of these places could be teeming with microbial life or just the ingredients for life, which is truly incredible. So, and the other thing that I find really amazing about Pluto is when New Horizons flew past Pluto, it took a long exposure and actually was able to showcase the atmosphere of Pluto. Yes, Pluto does have an atmosphere, and it has a nitrogen atmosphere. Just like our atmosphere mostly is nitrogen. That's what gives us the blue hue that we have in our atmosphere. This is exactly what we see with Pluto. So, you have this active, active movement and changing of the crust on Pluto. You have mountain ranges, you have glaciers, you have a nitrogen atmosphere. I don't care if you call this a dwarf planet or a planet. Pluto is awesome. And there's actually a t-shirt, I forgot to throw it in there, but there is a t-shirt and there says Pluto's awesome. That is the most legit nerdy t-shirt you can buy. And I recommend getting that instead of the Rest in Peace Pluto one. Get the one that says Pluto is awesome. That's the one you want to buy because that is the truth. Pluto is this little awesome world out there, billions of miles away from Earth. So very, very cool thing. So now I want to kind of switch gears. We've been talking about Pluto for a little bit here. And now I want to talk about something else that I hear a lot about. This isn't really a misconception per se. I wanted to throw it in there because it's just a chuckle thing, but I really want to get into the history of this and why do we call it this and why is this name so funny and things like that. Well, it's this object here. If you know what this is, you probably are already chuckling behind your computer, already thinking where I'm going with this. This is an ice giant found in our solar system. It's past Saturn. It's the seventh planet from the sun. You're probably thinking there you go. Did you know 63 Earths can fit in, Uranus, 64 if relaxed. Now, here's the thing. We always make this joke about this planet, but technically the proper phonetic is Uranus or Uranus. So technically Uranus is the not quite way that we should say it, even though it's technically still kind of correct. But why do we even call this planet this name? Why is this thing, called what it is? How did we discover this world? All that good stuff and all that. Well, believe it or not, Uranus and Neptune are modern day discovery, and of course Pluto. But when we say modern day, we're talking the last 500 years or so. The ancient planets, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, were known by people from antiquity because they were visible in the sky. They were the wanderers of the stars. They were called planetes in Greek, which means wanderer. But when it comes to these worlds that are very far away in our solar system, like Uranus, they were discovered by modern astronomers. When we say modern, we're talking, again, the last, since the scientific revolution, since Galileo and that. And here we have William Herschel and Carolyn Herschel. We call them the Herschels. The Herschels were really considered some of the very first true professional astronomers. William Herschel was hired by the King of England, King George, to essentially, he was the royal astronomer. And actually back in the day, astronomy was a big deal, especially, tabulating times and star positions and all that. And so it was actually a big deal to be an astronomer royal back then. And Carolyn Herschel was taught by William mathematics and astronomy, and she was a very, very important role when making these discoveries. She was assisting him a lot, but then eventually she discovered galaxies and comets and all kinds of amazing things on her own. And this is me here next to a replica of the telescope that William Herschel used in his little garden, and behind him, actually standing in the actual house in Bath, United Kingdom, where he actually discovered Uranus. So he took that telescope, well, not that one, but the one like that, outside in his garden, and was sweeping the sky and discovered Uranus. And you can actually see Uranus through a telescope pretty easily if you know where to look. And I know Frank and I have both been able to capture Uranus using our planetary cameras, and maybe one day we'll be able to show you Uranus through at one of our star parties here. Maybe we'll do a program about the planets or something like that. So anyway, so Uranus was discovered by, and this is in the late 1700s. So again, very, very recently, if you will. But back then, Uranus was actually not named Uranus. It was actually named the Georgian star, or George. I don't know which one is better, Uranus or George. So we have, well, let's talk about the planets. We got Mercury, Venus, Earth, Mars, Jupiter, Saturn, George. It doesn't have the same ring. And so for a while it was called the Georgian star, but then the astronomical community decided, said, that's not quite the right thing. So we're going to go with a different name, something that kind of honors that Roman counterpart. So Mercury is the Roman messenger god. Venus is the Roman goddess of love and fertility. Terra, which is actually Earth's real designated name. Terra is the goddess of the earth. Mars is the god of war. Jupiter is the god of storms and is the ruler of all these gods. Saturn is actually Jupiter's father. In Greek, it's Kronos. Well, believe it or not, Uranus actually isn't a Roman name. It actually comes from Greek. It's a Greek name. And Uranus actually is the father of the Titans. So Uranus was the father of Kronos, or Zeus's grandfather. So the reason why we kind of designated this planet as Uranus is actually going with that kind of idea that Jupiter, then Saturn is the father of Jupiter, and Uranus is the father of Saturn, or grandfather of Jupiter. So that kind of is the designation. Now, why is there no Latin name for Uranus? Well, it's actually the same thing. They, I guess, didn't Latinize the name. It just stayed the same. So that kind of explains that whole thing there. So now you kind of know where this planet's name came from. And if I have friends of mine who are fluent in Greek and who are from Greece, and they would say it's Uranus. So if you want to be really technical about it, you want to call Uranus, that go for it. But Uranus is also another one, and technically Uranus is still correct. So as funny as it is, it has many different pronunciations. So but to kind of eliminate a lot of the chuckles, the more appropriate or more proper one that we use now is Uranus. But anyways, I thought it was just kind of a fun thing to talk about, to see that on t-shirts, see that on jokes around the world. And now you kind of know a little bit about the history behind this ice giant world. So that's actually all I have. I know that originally it was set to about 20 minutes or so for the talk. So I wanted to kind of keep it at that, but also give a chance for any question and answer. So that way we can continue on. But thank you so much for listening. And I hope that you found it entertaining and learned a little bit tonight. So thank you so much.
Great. Thank you so much, Derek. And everyone that's out there tonight, if you have questions for Derek, go ahead and type them into the YouTube chat right now. I'll give you a few minutes to be able to do that. And I'll talk to you a little bit about how the rest of the flow of the evening is going to go. And Derek, by the way, thanks again, because everybody is so happy. Awesome. Hi, Stephen Brown from Arizona. I'm so sorry. You should actually be in the Zoom. Sorry about that. I'll fix that momentarily. Stephen Brown is in the chat now, and he's one of our volunteers. He's supposed to be helping moderate this evening. Shame on me. So the rest of the evening, as we're waiting for any questions to come through, so you guys kind of understand, is we'll go through different objects for the evening. We're having really poor weather in all of our locations, which is Florida, Virginia, Arizona, and the Canary Islands. So the entire Northern Hemisphere, except for apparently Illinois, as we've heard in the chat, is experiencing poor weather. Even at my house, now of course, I live in the Sonoran Desert in Arizona, and a lot of you may not believe this, but it's going to snow at my house. And it's going to snow at our observatory. So we've made a few jokes in the chat with you all that we have considered trying to transport our observatory to warmer climes, and nobody's taking us seriously. So, we're sort of stuck with what we've got. If the director of the observatory is out there somewhere, maybe he can tell us if there's snow on the observatory right now. I did check our all sky cams this morning and didn't see any snow on the ground. So we were clear at that time. So let's see. So we do have a couple of questions here in the chat, or at least one. So Derek, Kimberly Reed from Florida would like to know, when will the Andromeda galaxy hit us?
I mean, I can't say the exact day at the exact time, but we're talking billions of years from now. So very, not in any of our lifetimes, or our great. I mean, we go on forever. Great grandchildren. But it's going to be a while. And when we say collision, we're not thinking. We're thinking it's not like going to be two cars that are going to smash together. They're going to interact together. They're going to share, this gravitational attraction. They're going to move stuff around, and eventually two new I always make this joke in my programs. Two new galaxies will come out of this process. And I always make the joke, it could be the Twix and Snickers galaxies, to go with the Milky Way. But we're talking billions of years in the future. So nothing to worry about.
Well, that's not as exciting as we want it to be.
No, it's not. No, I know.
We want you to say tomorrow.
Not tomorrow. Well, no.
Speedy collision.
Tomorrow, billions of years from now. I mean.
Oh, and so Eric Hoyne has asked, do you have some recent planetary images that you could share?
I do. Actually, Frank and I both have it, right? Because we did the Jupiter-Saturn conjunction. Let me just go through. If you give me just a second here, I'll bring those up. Let me go ahead and find them in my my folder here. So,
while you're doing that, I'll actually answer the next question, which Eric asked if Frank is online, and he is. He is out here with us. He's gonna. Well, he was supposed to run a telescope. Now he'll run images. So Frank, if you want to just say hi to everybody.
Hi, everybody. Be with you shortly. We got some cool stuff to show you.
I got to go through all my millions of folders here. That's the problem when you take all these pictures. You got 8,000 folders to go through. So
let's see. Well, so anyone on the chat, Brian, John, if you want to pop in too as well. We have a question about, oh, no, we didn't. We had a statement, I lied, that the antenna galaxy is a byproduct of two galaxies colliding. So if anybody wants to pop in and chat about that for a second while we're pulling up planetary images, feel free. Anyone can go ahead and unmute themselves for that. But actually, I probably should do what I said I was going to do, which is tell you how the night is going to flow. So I think we have Derek and Frank will come up first anyway to show you what their objects were going to be tonight. So they can show you some planetary images as well as their astronomical objects. And then we'll move on to Brian Cummins, who is a NASA JPL Solar System Ambassador in Chantilly, Virginia. And then we will move on to the Sonora Astronomical Society with John Dwyer. They're a good community partner to Fred Lawrence Whipple Observatory. And in the before times, they always ran telescopes for us at our standard monthly star party. And so we hope to be able to do that again in the future. And then we'll come back to me for our last object of the evening, and then we'll close out. So Stephen Brown, if you are out there and you are hearing me, I have sent you an invite to come back into the Zoom room. And so I'll hand it right over to Derek and Frank, and they can get started.
All right. Well, I guess
other objects.
Yeah, we'll segue to the picture here. So here's an image of the Jupiter and Saturn conjunction that occurred back in December. So this was fun. Frank can probably. I'd love to show yours, Frank, too, if you can throw it up there after we're done. But we were hosting a large star party event of our own, and trying to do all this while managing a star party was fun. But this is actually a combination of several exposures. So in order to get Saturn bright and the moons of Saturn bright, I had to expose a lot longer. And so this was actually a combination of actually 4 separate images. So what I did is I exposed for Jupiter, and then I increased the exposure a little bit to capture the moons of Jupiter. And then I exposed it even more to capture the features of Saturn. And then I exposed it even more to capture some of the moons of Saturn. So what I did is I took all 4 of those separate images, and then I layered stacked them together to create this final image. And actually, we do that a lot generally with planetary imaging when it comes to observing the moon stuff. It's just impossible to expose for one versus the other. because one's much brighter than the other. So a lot of times you have to expose multiple different ways in order to capture the moons and the planets. So this is actually fairly a normal procedure that we do in order to actually showcase all the different aspects of the planets. So I'm going to go ahead and give it over to Frank, because Frank, you have your version of the picture too.
Yeah, I just pulled that up for you as well, and this was taken on the same evening. Am I on? I think. Hang on a sec. Let me spotlight myself. There we go. Yeah, so same evening there where we did that event for the conjunction there, and this is what I was taking right before we actually went live. This is just a single exposure here as opposed to the multiple exposures that Derek did to pull out those moons. But even with a single exposure, I was able to suck out some of the moons around Jupiter, and we've got a pretty clear view of both Jupiter and Saturn here together at almost at their closest approach. So that was a fun night. So by request, planetary images.
If you have, for those that are watching in the Star Party, or for those that are actually part of the panelists here, I had a chance for a hot second to put an eyepiece in actually my bino viewer. So actually I was using a pair of eyepieces that were together to create almost binocular vision, and seeing the two together, and that was unbelievable. No words can describe seeing it through your eyes. And it kind of pained me a little bit that we weren't doing a physical event where we could have people come out to the telescopes and all. I'm sure everybody else will agree with me on that. However, it still was extremely amazing to be able to showcase this thing, because a lot of people that attended our Star Party couldn't do it because it was cloudy. So we were kind of their saving grace to see it. So we were very thankful to have that opportunity.
Totally, yeah.
So what are we going to look at first tonight, Frank?
Well, like we said, it is kind of cloudy here in Central Florida today. And let me spotlight myself again here. But not to worry. I took some footage a couple of nights ago when it was clear, and we're going to show you some really cool live time-delayed views, if you want to think of it that way. And we're going to start off in the vicinity of Orion. So if you take a look over toward the east, and you do have clear skies, can't miss Orion. It's way up there, and you'll see its iconic belt. And if you zoom in toward the easternmost star of the belt, that's where we're going to be starting this evening. And as you go in toward Alnitak, which is that easternmost star, you'll see the iconic Horsehead Nebula and its neighbor, the Flame Nebula, as well. So let's go ahead and kick off things with our telescope and see if we can get a view of it. So let me switch on over to our telescope here. And this is my telescope a couple of nights ago out in my driveway here, and it's already pointing at the Horsehead Nebula. And we just have to tell it to start taking images for us so we can actually see what it looks like through the telescope from my driveway here. I've already pointed it at the right part of the sky here, thankfully. Save a little bit of trouble there. And what we're going to do is called live stacking. The idea here is that we're going to take a bunch of 30-second exposures of this part of the sky and keep adding those pictures together. So over time, every 30 seconds, this image is going to get more and more clear as time goes on. At least that's the hope. This is a very dim thing to look at. So it will take a very sensitive, specialized camera to pull this out and a fair amount of exposure time. But given 5 or 6 minutes, which is about what I'm going to spend on it with you right now, we should be able to see some pretty good detail. So let's see what we get. We're just waiting for that first 30-second exposure to come in right now. And 2, 1. All right, that exposure is complete. It's downloading it now to our computer here in the office.
Always like Christmas time, isn't it? When you're like, oh, is it gonna?
I know.
There it is.
There it is. Very faint. You know, it's only been 30 seconds, but it will get better as we throw more exposure time at it. But already, you can see the Flame Nebula to the left there. The Horsehead is starting to emerge up over on the right. And toward the upper left, you can see that bright star Alnitak in between the two. And as we get another frame in here, it should look even better. Horsehead Nebula, this is what we call a dark nebula. So it's not actually a hole in that nebula. It's actually this cloud of really thick, opaque gas that's in front of the nebula, blocking the light from reaching you. So it's really more of a shadow that you're seeing than an actual gap in that nebula behind it. It's also known as Barnard 33. We just got another frame in there too. I'm gonna increase the brightness on that a little bit to pull it out a little bit more and make it a little bit more visible on YouTube, hopefully. There we go. That's a little bit easier to see now. And we can start to see some of that structure. It's going to look a little bit more clear, a little bit less noise as time goes on. And interestingly, this was actually, although it's attributed to Barnard and is called Barnard 33, it was actually first recorded in 1888 by a Scottish astronomer named Wilhelmina Fleming. So a woman actually discovered the Horsehead Nebula at the Harvard College Observatory, which I believe has some connections to our host tonight.
It does. Thank you so much.
Yeah, a little shout out there to Harvard. So. But yeah, it's a little interesting bit of history. But yeah, it's kind of like this dark cloud of gas. And as we get more and more time on the Horsehead here, you might start to see some of that gas kind of becoming visible underneath it that is kind of oozing out of, if you will. And actually within that gas, there's new stars being formed as well. This is going to be true of a lot of the nebulas that we look at tonight, where these clouds of gas are coming together and forming new baby stars. And some of these stars have protoplanetary disks around them as well. So there could be entire new worlds being born within the base of that Horsehead right now as we speak. Hard to see right now, but there are some bright spots toward the base of the neck there that we think are actually young stars being formed. So really cool. Let's zoom out a little bit and let's see what else we can find. Looks like my network froze up a little bit there. There we go. So let's take a wider view here and take another look at the Flame Nebula. And you'll notice that it has sort of those dark tendrils in the middle of it there as well. And just like the Horsehead, that's actually clouds of dark gas obscuring the nebula behind it. So that bright star Alnitak, that leftmost eastmost star of Orion's belt, is emitting all this ultraviolet light that's ionizing the hydrogen in the Flame Nebula. But that darker gas in front of it is kind of making that dark pattern that makes it look like a flame. So it's this interesting interplay of different kinds of gases that make for very pretty things in the night sky. And the Flame Nebula itself is actually pretty interesting too in terms of star formation. You can't see it in this image, but at the center of the Flame Nebula, there's also a bunch of brand new stars forming there as well. And I looked it up. It looks like we think there's about 800 stars just in the middle of the Flame Nebula there, and 86% of them have circumstellar disks. How cool is that? So out of those hundreds of stars, most of them are actually forming these clouds of gas around them. And that's how planets are born, right? So, we can't say for sure if they're going to actually have planets when all is said and done, but it's really exciting to think about the possibilities of what might be forming out there. And just the fact that our galaxy is still producing new stars and new worlds, I think is very, very exciting. And, it's something to dream about, These are both about 1,300-ish light years away. So we're also looking back in time about 1,300 years ago. That's another cool thing about looking at deep space objects is you're not just looking really far away, you're looking back in time too, because this light took 1,300 years to get here to this telescope right here. And for the equipment geeks out there, this is a Starwatcher Starlux 190MN telescope, a Mach Newtonian in design. Sitting atop a Paramount Mighty mount and an Attic 383L Plus camera, which is a specialized astronomy camera that's actually cooled down to 10 degrees below 0 centigrade. Cool. 1,300 light years away. That's also 415 parsecs, if you want to sound like Han Solo. Parsecs is a measure of distance, not time, so we kind of got that wrong. Let's see if we can zoom in a little bit here and explore a little bit more before I move on to our next target. You see the Horsehead starting to look a little bit more defined there. We're starting to see hints of the cloud of gas beneath it that it forms out of. And we can also start to see another reflection nebula down toward the lower left there around that other bright star there.
I always thought it was more of a seahorse than a horse.
Yeah.
But that's just me. I don't know what. I guess we can make a huge debate on that. Should we call this a seahorse nebula or should we call this the regular horse nebula? But
well, now I can't unsee that, Derek. Thank you.
I see the chess piece.
Yeah.
Yeah. Okay. I could see the chess piece. We could be called the chess piece horse nebula.
There you go.
I don't know. I think we should call it the Fleming Nebula myself. Give Wilhelmina some credit.
Yeah, that's a good one.
Cool. Yeah. So this you could let this go all night, and I've done that. But for 10 minutes or so, this is about as good as it's gonna get. So I'm gonna go ahead. Well. Yeah, we can play around with the contrast here, try to make it a little bit more clear. But it's not going to get a whole lot better than that in a short amount of time. But last year, I actually took a much longer exposure of this part of the sky and let it run all night long with color filters. And when you do that, you end up seeing something like this. And this is what that part of the sky looks like. This is imaged through narrowband filters, so it's not entirely true color, but you can see more clearly those clouds of gas that the Horsehead is emerging from there, and some more of the structure of the filaments of the nebula that's behind it that it's actually obstructing. From what I've read, that those tendrils, those filaments behind the Horsehead are actually illuminated by the star Sigma Orionis, which is up in the upper right corner there somewhere. But the more time you throw at this, the prettier it gets, and it's a really gorgeous part of the sky in color as well. And Derek, I know you took a picture of this recently that was really awesome as well.
Yes, I guess I'll
pull it up if you got it, man. It's
yeah,
really
yeah.
cool.
Well, let me. I should probably been doing that while you were talking.
Well, I can move on while you're finding that. We can cut back to you.
Absolutely, yeah.
All right. So for my next trick, let's go back to Stellarium here. We're going to move a little bit over to the east here. So let me activate some of the objects here. And we're going to go from Alnitak over to the Christmas tree cluster. And this cluster does kind of look like a Christmas tree, but I think it's way cooler than that because there's all sorts of awesome nebulas going on in here as well, specifically the Cone Nebula. So that's what we're going to be focusing on next. And if you look closely here, yeah, it kind of looks like a sideways upside down Christmas tree, but the nebulas are what get me excited because, that's what I do.
All right, so I have the image loaded. So this is the image I took of the Horsehead a few days ago out at a dark sky site. And you can really see that there's more than just that. This is a very wide field view. So where Frank was kind of showing you this little area, there's actually this nebula, this hydrogen gas actually extends into a much larger part called the Great Orion Cloud Complex. It actually is combining, it's this massive area in the sky that contains all of this hydrogen gas. So the Horsehead is kind of just one part of that. And actually, if you see my background, which I don't think you can because I think he's Frank is spotlighted, but there we go. You can see there's the Horsehead here, but you can see it's part of this massive, I look like a weather person here. You can see this massive gas heading this way. That's part of that. So
we have a question for you guys. Are you using a hydrogen beta filter?
That was a hydrogen alpha filter.
Taking those beautiful images.
So when we were going live, that was actually a hydrogen alpha filter. And for the longer exposure I showed, that was actually a mixture of narrowband filters, hydrogen alpha, oxygen 3, and sulfur 2. Derek, I'm guessing you were doing actual color there with yours, right?
Other color, however, hydrogen alpha is collected because of the fact that I'm using a camera that can collect all visible light. So hydrogen alpha is part of that. A lot of times if you want to observe the Horsehead and that area visually, a hydrogen beta filter, which you can attach to an eyepiece, really does enhance the view, and that enhances your ability to see. I've actually been able to see the Horsehead visually through a hydrogen beta filter through a large Dobsonian telescope. It's amazing if you get a chance to actually see it visually with your eyes.
Wow, really cool. Yeah, it's a hard thing to see even with like a giant telescope in dark sky. So that's something to cross off your list for sure.
Yeah, I mean, I have to tell you guys, so we've taken images on the MMT, which is a 6.5 meter primary mirror of the Horsehead Nebula, and you have to wait for those to process. So it's not quite the same as seeing it with your eye.
Totally. Yeah, it's
but I imagine it'd be crazy on a 6.5 meter. Oh my goodness, that's wow.
Cool. Well, let me start the imaging going on our next target here, the Cone Nebula. So let me give myself the spotlight again, because, that's how I roll. And we're going to slew on over a little bit to the east, like we talked about, to the Cone Nebula. And let's just tell it to head on over there. Off it goes, not too far away. And now we're pointing a little bit to the east and a little bit to the south to the Christmas tree cluster, and we'll start collecting some photons there. So let's kick off the live stacking there. Again, what we're doing is stacking together or adding together these 30-second exposures to get a better and better image over time, being piped in from the camera that's attached to my telescope. So let's go ahead and kick that off here. Actually, I'm going to move this down a little bit. It's a little bit out of frame, so I want to make sure we capture the cone part of the cone nebula. So I'm just going to jog that telescope down a little bit to make sure we get a nicely framed image here. And let's go ahead and start that. And actually, this is an even fainter. This is a very faint object. So I don't think 30-second exposures are going to cut it. Let's go to 60-second exposures instead and kick that off. So we're going to have to wait 60 seconds for our gratification this time, but it'll be worth it. It's a really cool object. This is one of my favorite parts of the sky, really. It's just absolutely beautiful in a long exposure. And when we're done with the quick look at it here, I'll reward you with a long exposure photograph of it that I think is pretty cool. Yeah, the Cone Nebula, it's, well, it looks like a cone, got its name pretty clearly. But the thing that I think is really cool, well, there's two things cool about this. One thing that's awesome is guess who discovered it? Do you know, Derek? I'll tell you.
I do not. No, I do not.
It was discovered by William Herschel,
Aha!
your buddy from Bath.
Yes.
Yes, so that if you remember the picture of Derek in Herschel's home next to the telescope that discovered Uranus, not Uranus. I'm going to call it George from now on. I love that. So yeah, same dude. You know, he discovered the Cone Nebula as well back in 1785. And I think our first frame is about to come in.
Here it comes.
Yep. Go, little camera.
The anticipation is killing.
Yep.
I can see a little bit of it.
Yeah, you can start to see the cone over to the right there. And again, the more time we throw at this, the more clear it's going to become. So we got to be patient. This is a dim one, but there it is right there. The cone is emerging there a little bit sideways from how you usually see it. But as we get more and more time on this, you'll see more and more detail emerge. This one's a little bit farther away as well compared to the Horsehead. This is 2,700 light years away. So,
Frank, sorry.
Yeah.
What is your lowest visible star magnitude where you are?
Ooh, I should know that. I haven't actually measured it. The short answer is I don't know. It depends how long you expose, right? So I'm more of an astrophotography guy. So basically, the more time you spend exposing your camera, the deeper you can go, and you can get some really faint stars.
So Frank, because I kind of know generally the area you're at, you could probably see. So so Amy is the person asking what you could see visually with your eyes, the limited magnitude for the sky, or if that's the case, then probably 5.5 or so is the limiting magnitude.
I think you're right. I'm like Bortle 5 here, so I think
terrible.
That is 5-ish. Yeah.
So, and of
You're
course,
Bortle 5. I'm sorry.
It's better than where I used to be.
I'm like, well, we're like a Bortle 2.5. So.
Oh, sure. Rub it in.
And you know, the funny part is one of the biggest light pollution contributors for where Frank lives is actually Kennedy Space Center. So I'm just saying.
Yeah. We choose to live with it. Rockets are worth it.
Got to light up those rockets at night, you know.
It's kind of funny when they like ignite them at night, like it actually lights up the whole sky here. Like it's like a major source of light pollution just for a few seconds though. That's
right. Yeah. But those xenons that they shine on those rockets at night can be brutal for observing. But you're not too far from dark skies though. It actually drops really fast when you get a little bit away from your area. So thankfully it does improve quite a bit.
Yeah, depending what part of the sky I'm looking at, it can be pretty good or pretty bad. So, you know, if you're looking south toward the cities here, not so good, but, you know, north is pretty nice. Anyway, we're starting to see more detail on the cone there. And you can see sort of that dark cloud of gas again. You know, it's the same sort of thing that was going on with the Horsehead, where we have this dark, more opaque gas sort of obscuring the nebula behind it. And it's actually being lit up by that bright star just to the left there. And we can also start to see more structure emerge from the larger nebula star-forming region that surrounds it to the just above or to the left in this image of the Cone Nebula. So we're starting to see sort of that wispy hydrogen gas that suffuses this whole part of the sky here. And again, the more time you spend exposing this, the more beautiful it gets. It's just a really gorgeous part of the sky. It's located technically in the constellation Monoceros, or is it Monoceros? I'm not sure how to pronounce it.
It's a tomato kind of thing. Yeah. But Monoceros would actually be more phonetically because ceros means horn and mono means one. So ceros like triceratops or ceratopsids, ceros. So it's just my deal tonight is to talk about phonetics apparently.
No, but I really want to call it Monoceros.
It does have. Cool. It does sound very like epic, like Monoceros, the unicorn.
Just wait till I have to pronounce my object's name.
Cool. Although if you want to get a real tongue twister, that star that's lighting up the Cone Nebula is called S. monocerotis, which kind of sounds like a disease or something. I don't know. I'm not sure how to pronounce that.
Yeah, you wouldn't want to catch that for sure.
This is a really fun
or
program.
Would you? You wouldn't want to catch it, right? Because then you'd be catching a star.
Ooh, that's romantic. Should save that for.
So what's also interesting too in this area is there's also a reflecting nebula. So there's different types of nebulas. There's emission nebulas, which is what Frank has been showing us with these hydrogen regions where star. But there's also reflecting nebulas, which are gases that are passing through star areas. And one of those is called the Fox Fir, which I believe you might actually have a final image of this, Frank, that kind of shows some of the bluer colors, and those are that light scattering off of those bright blue stars.
I'm going to cut to that right now. I think we've got enough time live on this object, and I'm running out of time. So let's go ahead and cut to that final image there. This is an image of this same part of the sky taken over 2 nights. So, close to 12 or 13 hours of exposure time, I think. And you can see that Fox Fir Nebula up there in the upper right there. And you can see that kind of like bluish tinge in that part of the sky there. That's the reflection nebula that Derek was talking about. So we actually have 3 different types of nebulas going on in this picture. We have the dark nebula of the cone itself. We have a reflection nebula up in that bluish area there. And the rest of it is an emission nebula, where that hydrogen gas is being ionized by the starlight coming into it. And hey, as an extra bonus, we have the Christmas tree star cluster in the middle of it all as well. And there's actually a huge amount of star formation going on here too. This part of the sky is chock full of what we call those T Tauri stars, I think it is. Did I get the name of that right?
Yeah, T Tauri, yeah.
Yeah, and these are like super young stars that are so young they're not even stable yet. And a lot of them we think have protoplanetary disks around them as well. So really cool part of the sky, and it's been an honor to share it with everybody. So hope you enjoyed it. Again, I'm Frank Kane, representing the Central Florida Astronomical Society. If you want to learn more about our club and you're living in Florida, check out cfast.org to learn more. And with that, I'll give it back to our host.
Nice t-shirt too, Frank.
Yeah, it's nerdy.
Yeah.
Oh, I mean, you guys are the top of the game here. But my images are not processed, so I feel
they're raw though. They're raw.
I always feel inadequate. Well, I think it's a different view, of how objects look for the very first time, and then they have to process again and again and again over time to get that full breadth of what they really look like. And so I love when you guys show those images and we really get to see this is what it really looks like when you process through all the filters and you get to see all of the gases and all of the dust. And especially from the different types of nebulae and the other types of objects out in space, because they are all so different and so beautiful in their own ways. And so it's really fun to look at that. So thank you guys again so much. And of course, stick around because we always love to ask you a million questions while you're here. And so next, we're going to switch over to Brian Cummins in Chantilly, Virginia. Brian, are you out there?
I'm here. Yep. Hey, thanks very much for having me again. It's a pleasure to be here with you all. My name is Brian Cummins. I'm an amateur astronomer, NASA Solar System Ambassador as well, and spent a lot of my time out, similar to Frank, out imaging. That's really where my passion lies in astronomy. So I thought I'd share with you some pictures that I've taken recently.
Brian, sorry, before you do that, will you tell everyone with us tonight, what are Solar System Ambassadors?
Yeah, so the NASA and JPL have a program for outreach to the community. It's called Solar System Ambassadors, and what we do is we apply to the program, and if you're accepted, we have we do lots of public outreach. It can be in schools, classrooms, can be at star parties, virtual and live, kind of like we're doing here tonight. Really to educate and provide outreach about NASA, its programs, about space in general. And again, there's all kinds of opportunities. And Amy, I know you participate in these as well. So if you are looking for an event, or you're looking for someone to come to an event that you have, or a group, maybe scouts or at a school or classroom, look up on the web. Just look up for NASA Solar System Ambassadors. There's a directory of us that you can look for your state and find someone that potentially can come out and talk to you about what you need. So yeah, that's what the Solar System Ambassadors are. So very proud to be part of that, and also proud to be part of the astronomy club that I'm part of, which is the Northern Virginia Astronomy Club, and novac.com. It's, I think, the biggest astronomy club in the country, and similar to what Frank's does is we have outreach events where we have star parties that you can come to in person and look through our telescopes, see different types of gear. We do presentations. We have scope loaner programs. We have dark sites that you can go to if you're a member and want to use your telescope. So lots of great things that that the club offers. I'm going to show you some images taken recently. Unfortunately, the weather tonight is not cooperating so much. We have clouds in the air, we have wind in the area. None of that works particularly well for astrophotography, so I figured I would start from home. These images were taken with this telescope here. This is my refractor telescope. It's a 127 millimeter aperture refractor sitting on an equatorial mount. This red guy right at the back, if you can see that, zoom in, that red guy right at the back, the bigger one, is a dedicated astronomy camera that I use for capturing images. All these wires actually make their way back to the laptop that's hiding in this tent, where I control the camera, the mount, kind of everything that I'm using for imaging for the night. So I'll show you what this would look like. So I'll tell you what, similar to these guys, all of my images are in and around Orion tonight. This is, for a lot of us, I think Orion is, one of the favorite constellations. And every time, winter starts coming around again and Orion starts popping up, it's, like seeing an old friend again. And so where we're going to start, if you look at Orion and are unfamiliar with what the constellation looks like. So Orion the Hunter, he's got his, I guess, shield out here. His sword kind of hangs down in here. This is where we're going to start looking, is in this area, which is the Great Orion Nebula. We're also going to look at the Running Man Nebula. So if I flip over to, this is the software that I use for running my camera, controlling my mount, keeping an eye on everything.
Ryan, you're not showing anything right now.
My goodness, what a rookie mistake. I forgot to share my screen.
Good thing someone out there was watching that.
I know, right? I wasn't. All right, so apologies. I will show you back to the rig. So this is the picture of my telescope. This is my refractor sitting on an equatorial mount. All these wires come back to the laptop here. And I mentioned this red guy right back here is the camera that I use to collect these images. So apologies for that. And thank you for pointing it out to me. Okay, so, and this picture was taken from one of the parks I like to go to. It's Sky Meadow State Park in Delaplane, Virginia, maybe 45 minutes to an hour outside of Washington, D.C., which you may have heard of recently in the news. This is what it would normally look like if I were taking images of the Great Orion Nebula and the Running Man Nebula, which is over here. So this is the software that I use to run the sequences, to take the pictures. As Frank mentioned, these images are taken over multiple nights, and they are essentially put together a stack of lots of shorter duration images. I think this one was 45 seconds. And to get the final image that I'll show you was taken over multiple nights with lots of images of 45 seconds each. To show you what that looks like, or kind of when we start. So this is actually, when you first pull up the image in the tools, this is kind of what it looks like when you first put together the color image. The software that I'm using here is what we use to process the images, start to bring out data. And this is not a bad version, but there's all kinds of tools and processes and scripts that we use to sort of clean it up, make it look beautiful, clean up the noise. And what we end up with is something more like this, which is, this is the Great Orion Nebula here. Huge area of dust and gas. It's about 1,300 light years from Earth. It's about 24 light years across. So just huge. And this is a stellar nursery, similar to what Frank had shown. Lots of brand new stars in here that are ionizing this gas in the nebula, some dust hanging down. This one over here that's kind of reddish pink is sort of that running man that, I don't know if you can sort of see that, but I don't know, sort of turned a little bit to the side. So that's the Orion Nebula. Okay, so the next one I wanted to show you is, let's see, what do we want to go to next? Let's go to NGC 2174. I'll show you where that lies. It's not far away from Orion. Again, it's up in this area, kind of up high in the screen. Okay, so I will take you to a final image of, this is called the Monkey Head Nebula. So this guy, also an area of stellar formation. You can see some of these stars in here are some of the newer stars that are illuminating this dust and gas. To give you something that looks a little like a monkey head, and if you're having problems seeing it, as some people do, I'm going to actually show you an actual monkey head and tell you, okay, so now it's sort of that monkey profile, and it gives you something to look at that says, okay, yeah, that does look a little bit like a monkey head. That is about 6,400 light years away. It's made up of hydrogen and oxygen and dust. This image was taken using narrowband filters, so this is not an exact representation of what it would look like, sort of if you did a point and click camera at it, if you could, but it does show in some pretty nice detail those areas of gas and dust that I wanted to share with you. And let's see here.
I have to just tell you, like, I'm so glad you showed the profile of the monkey because whenever I see that, right? So like normally, so for those out there who don't know, I also run a telescope for his Sky Nights program at the University of Arizona's Mount Lemmon Sky Center. And of course, in the before times, we can't do that right now. But, when we look at things, sometimes through the telescope, you don't have an image handy to show people why is that an owl? Why is that a monkey?
Yeah. Yeah, this one's a little tougher. Once you see it, it's kind of hard to unsee, but I figured I would show you an actual monkey head profile that to me makes it a lot easier to see. Okay, so the last one that I'm going to show, unless I guess I got a couple others I could show you, but
I think we can let you go a smidge over time if John is okay with it.
I won't take John's time. It's fine. I will. The next one I'm going to show you is Caldwell 49, also very nearby. It's for some reason it's not cooperating. Well,
also technically, remember we started 5 minutes late, so you can take a couple more.
So I'll keep moving. I'll just tell you it's close by. This is the Rosetta Nebula, which is over in Monoceros or Monoceros. You guys are going to mess me up on that. I'm going to pronounce it wrong for the rest of my life now. But this is the Rosetta Nebula. This one is about 5,400 light years away and about 65 light years in diameter. Again, this is another emission nebula. This was taken over 2 nights using narrowband filters. It's a huge area of gas and dust that is another stellar nursery, and kind of the star cluster in the middle is a bunch of the stars that were formed as a result of this. And I think even the result of those stars being formed is sort of what's blowing out that donut hole in this. So yeah, it's a really cool area of the sky, that Orion Nebula. You've seen a bunch of things from there that are very close by. You've got the Orion Nebula, the Running Man Nebula, Horsehead, Rosette. There's all kinds of stuff. Crab Nebula is not too far from there as well. So when Orion comes up in the winter and we have nice long nights where we can gather lots of data, it's really a good time of year for astrophotography, aside from being out in the field and being very cold all night. So those are the 3 images I brought. If there are any questions, happy to take them. I know someone asked for a couple planetary photos. I brought, so I pulled up this one of Jupiter that I've taken previously, and this one of Saturn that I've taken previously. These weren't taken at the conjunction, and those guys did an excellent job of grabbing those two images. The conditions that we had, it was great to look through the eyepiece, and seeing those two planets in the same eyepiece was super cool. The conditions of the atmosphere were really wavy, that the seeing was not particularly good, and so capturing an actual image from where we were was very difficult, but easy to see with the eye, which was an awesome event. So I think that's what I was going to share with you tonight, Amy.
Well, thank you so much, Brian. We really appreciate you coming out, and it's interesting, that this is the first time we're not out in the cow field. So
we've had like 3 in a row, which is great.
It's a little different experience to like see you in a lighted area.
I know, and warm. Yeah, we've had good luck with weather the last few times, right? I mean, actually being able to be outside and show you live views, but hopefully this was okay tonight. Yep.
Yeah, it worked out great. I think we're doing really well. So we'll move on next to John Dwyer from the Sonora Astronomical Society. And I introduced John before, but I really want to give a huge shout out again to our friends at the Sonora Astronomical Society for all the help that they give to Fred Lawrence Whipple Observatory. We traditionally hold our live star parties off-site at another dark sky location because for those of you who are in Florida or Illinois, at our observatory, we have about 30 telescopes, and a few of them are what I would say basically in the parking lot. So some of our gamma ray telescopes ended up right outside of our science center, literally just less than a football field away from my office. There's one about 100 feet away from where my office is in the building. So we don't hold star parties on our site. So we rely on our great community partners to help us out with a number of small telescopes at another site. And so without further ado, I would love to welcome, and I hope you will all join me in welcoming John Dwyer from the Sonora Astronomical Society.
Thank you, Amy. We're always happy to give a star party to the people around here in the Green Valley area. And hopefully one of these days we can get back to it. We get past these problems we've been having. So I'm going to be working on the moon tonight. I'm live. The sky is clear here. It's a little bit windy, but that's tolerable. Let me bring up the screen here. I'm gonna have to, if I can do this. Okay, let me move things around a little bit. It's drifting a little on me.
And John, for anyone who we actually have a few people here tonight watching who are relatively new to observing and relatively new to astronomy. So since we're so zoomed in on the moon, and if you don't mind taking a second to talk about why that's happening, why that image is shifting so readily to our eye.
Pardon, could you repeat that, please?
Oh, yeah, I was just hoping you could, from your own point of view, explain to all of the guests tonight about the rotation of Earth, and so why we actually see that image moving pretty rapidly. I'm like watching the moon, and it's just shifting. And so if you want to just take a minute to kind of talk about why that happens, and so why we use some of the softwares that we do in astronomy with small telescopes, or any of the other speakers can feel free to pipe in as well and talk about it.
Well, I mean, it's moving right now. We only see one side of the moon from the Earth, and this one side has a lot more features than the other side, which is a good thing. But the moon moves like, I think it was like about 12 degrees a night, and it's moving from west to east as it orbits around the Earth. And there are a number of features that when early astronomers back several centuries ago finally got a hold of some telescopes, they were amazed at what they were seeing, and they couldn't quite make sense of some of what they were seeing. Right now, I have these dark, almost circular areas of the moon are called Maria or seas. That's what the astronomers several centuries ago thought they were, because that's what they looked like to them, and so they named them as seas or Maria. The one on the up here is called Mare Crisium, or Sea of Crisis. And then a lot of these have Latin names. That was the language of science back then. So a lot of these are signed as with Latin names. Some of them are a little tough to pronounce. But this is Mare, Sea of Crisis. This is a kind of a famous sea right here, called Sea of Tranquility. That is where the first landing of man on the moon occurred with Apollo 11. It landed about in this area right here. The very last Apollo mission to the moon landed about in this area here. This is sort of the sort of the right on the borderline between the Sea of Tranquility and this is the Sea of Serenity. We had from 11 to 17. There were other areas where some of the other missions landed. Let me move around a little bit here so I get some more objects. And let's see here. We'll move it over a little bit. Let me zoom in a little bit here. There you go. What you see here is it's called the Epidine Mountains. There's mountains on the moon. There's obviously craters on the moon. There's seas on the moon and various other types of objects. This happens to be, as I said, the Epidine Mountains. This particular crater here is Eratosthenes. Let's see here, what else we got here? And I think if we move over a little bit more, let's see here. I believe this one is Archimedes. So some of these are kind of embedded in these seas, and actually, what these seas are is it's like lava, like we have on Earth, basaltic lava, created by either impacts or volcanic eruptions off the moon, and as I said, the Marias are basically on this side of the moon, and supposedly was caused by either interaction with the Earth's gravity or heat from the Earth that caused heating of the moon on this side, and the other side was not as affected as this side. Okay, let me see what else we get here. Okay. Oh, wrong way. Okay. Yeah, wrong way again. There's one particular phenomenon that occurs on the moon just before first quarter, and it's called the Lunar X. And I think we might be able to see where it's based in. Let me see here. Wrong way again. It occurs right in this area. I'm going to move down me here. We moved down me. It occurs right in this area here, where the just before first quarter, the sun hits the top of some neighboring craters, and it actually forms an X. I think you might be able to see the area right here. Let's see if I can zoom in a little bit more here. Might be too far. I don't know if I got it here or not, but it's a very interesting object to see. Again, it only occurs just before the first quarter, and you have to be in the right spot at the right time in order to see it. And it lasts about 4 hours. First time I saw it, I never realized there was such a phenomenon. I happened to be at a star party at a local school, and I was looking through the telescope and I saw this bright X on the moon, and I didn't know what that was. I think it's it here. It's hard to see. Right now, it's past the point where it'll be shining, but it's a nice phenomenon to pick out. But you only see it certain times during the year. You have to be in the right spot in the right time. And if you have a telescope and there's places online where you can find out what dates and times this phenomenon is visible. It's really something to see. And there's also another called a lunar Y, or lunar V, I'm sorry. That's a little bit further north. I don't know if I can find it or not. Yeah, it's right in this area here. It caused the same sort of phenomenon, except it makes a V out of it instead of an X. So those are two phenomena that you can really look nicely, nice to show people. Let's see, what else we got here? Let's go back. Am I still taking images? I didn't do Zoom. All right. So let's see what else there is here. Got some more craters, maybe. Again, those are the mountains. And I thought, if I can find Copernicus, I think, yeah, I do believe I think this is Copernicus right here. Let me see if I can, let's center it a little bit.
For all of our star presenters out there tonight, how do these craters get their names? There's so many of them.
Yeah, that's a good point. I don't know how they, I guess they named it after, sometimes after people, like this was Copernicus here. Let's get it in a little bit
Derek,
more.
you seem to know these things. Since you're all about names tonight, Derek, maybe do you know how they all get their names, or like what the naming schema is?
I'm trying to find the mute button, because my dock is obscuring it. So basically it's the same thing. The International Astronomical Union will annotate the names. They've been discovered by people over the course of the centuries. They would observe these things and they would name them. So it's kind of a mixture of different things. But the more recent ones, though, they're usually designated by the IAU. if there's a new crater that's recently been discovered, or a new impact site or something like that.
Thanks.
Okay, that's about it for me.
All right, well, thank you so much, John. And I'm going to go ahead and maybe, Mike, I've done some things over on my side. Maybe one of the other hosts will help me out here. All right, there we go. Okay, so everybody, so we're going to move on to our last object of the evening, which is with me. Again, I'm Amy Oliver from the Fred Lawrence Whipple Observatory. And lately we have been using a telescope in the Canary Islands with the help of our friends at Slooh to take some images and to help you guys see what the night sky looks like and what some of the objects look like in other areas of the sky. So sometimes we use a telescope in Chile, and sometimes we, excuse me, I'm going to go ahead and stop your share there, John, and bring it over here. But so we sometimes use a telescope in Chile, and then we sometimes use a telescope in the Canary Islands, and there are a number of different ones at Slooh. So we have been very lucky to be able to have that opportunity. And you'll have to forgive me because I am IT tonight as well. So this is going to be a little bit of a strange juggle between running some of the IT stuff and also sharing these images. I have about 900 windows open to run this event on my computer. So we're going to figure this out. All right, so I'm going to first share with you some black and white images, and then I will share with you the color image. Now, the difference between the images I'm going to show you and some of the images you saw from Brian and from Derek and Frank is that my images have not yet been fully processed. So I have not stacked these images, and I haven't had an opportunity to really play with the hues in Photoshop or another editing software to bring out all of the colors. And so what you're seeing is first the primary image taken from Canary 2 in the Canary Islands, and then second, the color filtered image. So tonight we're actually looking at, let's make sure you guys can see that. So do you all see this kind of glowy blob? I think it looks like an angel or a ghost. But this is
I see a manta ray.
You see a manta? You know what? I see it. I get it. Yeah, I see the manta ray. Like now all of my stuff is gone. By the way, everything disappeared off my computer because I touched one thing. So I'm just like, but anyway, what we're looking at is Demi-Raines Nebula. And this is an Emission Nebula. And while I am looking for everything, there we go. I'm like everything on my computer. So Emission Nebulae, it's a Friday night, everyone. Can't say words tonight. Emission nebulae can range from anywhere between 100 to 10,000 solar masses. So you think about that, we're talking about the sun, right? So 10,000 times the sun. And they can span from 1 to 100 light years in size. And what they're made out of, so what you're actually looking at here is a cloud of hydrogen gas that has been either excited or ionized, okay? So why we sometimes see color in these types of situations is because you have hot nearby stars, okay? So we're talking like greater than 25,000 degrees Kelvin. So O or B type stars. So for those of you who are not familiar, earlier we were talking about Williamina Fleming, and during her time, there was also a woman named Annie Jump Cannon among the Harvard computers. And she came up with, "Oh, be a fine girl, kiss me," which is the classification system for stars. Okay, so we're talking about O and B type stars. And those produce high energy ultraviolet radiation. So I'm going to stop the screen share for a second. And that was a mistake. Like, all hell's breaking loose. Oh, I said a bad word on Zoom. My boss is here. Sorry. Okay, my screen is missing. Let's see if we can find it. Where is our zoom? I don't know where our zoom is. So I'm going to keep talking while I'm looking for our Zoom session.
It might be up in the upper right-hand corner. That's what happened to me.
It's just gone. Like, let's see. I'm staring at every part of my computer.
Are you on a Windows machine or Apple or Mac?
I'm on an Apple machine.
So, are you on?
We came back for a second and then it went away again.
Okay, I was saying, if you on your keyboard, are you on a laptop or?
You don't want to know what's going on over here. Okay, I got it. We're good. Okay. We're good. Everything came back. Okay. It's okay. We're back. Okay, so I'm going to share the second image because I want to talk to you about these colors. Okay, so UV radiation. Look, we're back. Okay, tech problems abound in the Zoom environment. By the time we have all the tech problems figured out, we'll be back in person. Okay, so 2 years from now. All right. The UV radiation, okay, from the nearby hot stars excites hydrogen atoms and they release photons, okay? And photons are a basic unit of light. So they're a particle that carries electromagnetic force. And so the release of photons is what's creating these colors in the emission. Okay, so when you're seeing that pinkish color there, and it's actually very red in this particular image, so you're getting that really, really deep, thick color. It's because hydrogen actually has low ionization energy. And hydrogen in this case makes up 90% of the gases in Day-my-Rains. Okay, so if you're looking for this and you're new to observing, it's also known as M43 or NGC 1982, depending on which catalog you're using. And it is a star-forming nebula, which means that baby stars are being born here. We love star nurseries, okay? And it was discovered by a French scientist named Jean-Jacques Dortu de Mayrain. Look, I said things in French. I'm proud of myself. If my boss is out there, hi. My boss is French-Canadian. This was discovered sometime before 1731. Okay, so when we're talking about looking, being clear back in time and seeing these things through these telescopes that they had in 1731, imagine this amazing thing that they were looking at. And it was cataloged in 1769 by Charles Messier, which is how it became M43. And it's physically, since Brian was earlier talking about the Orion Nebula, it's really important to know this is actually physically part of the Orion Nebula. Okay, so it's separated from the main Orion Nebula, and maybe Brian can come back and bring up the Orion Nebula again, and you can sort of look for this feature in there. And it's separated by this dense lane of dust known as the Northeast Dark Lane. But it is a part of that much louder Orion molecular cloud complex. And so, and if you remember Brian's image and how beautiful that is, this is, in that eye, basically, of the Orion Nebula in that cloud. So this is a really beautiful, just to look at, just to, as we take these sorts of images, they process over the course of about 2 minutes. So a little bit faster than Frank and Derek were doing to come to this particular image that is filtered in color. And so it's a really beautiful example. I'm gonna actually skip to the other color image that I took of this because I think that you'll all recognize what it looks like in the Orion Nebula when I show this to you. So for those of you who know what the Orion Nebula looks like, this is very recognizable. This is a truly recognizable component of the Orion Nebula. And later when I finished processing this, it'll look a lot more like Brian's image as well. So Brian, if you're still out there, I know you are, if you want to bring up your Orion Nebula image again, that would be great. And then everyone can just see as that last image what this looks like in there and really start to look for it so they can begin to recognize features.
Yep, there you go. And I think yours is, if let's see here.
Oh, I see it.
Yeah, I think if we, yeah, my tools are hiding behind my pictures of you guys here.
You're also
Okay.
having tech problems tonight. Everything's tight.
Yeah, so yeah, I think if I just, I think if you do that rotation, I think this is kind of the more the orientation that you've got for yours, Amy, right?
Yeah.
I think that's kind of look like that's that bright spot in the middle of yours, and you can start seeing some of those dust and gas lanes hanging down. I think that's what you were, I think that's sort of the orientation that you've
Yeah,
got
and
in
so
there.
I love your image because it is so beautiful, because it brings out all of the other gases and dust in the Orion Nebula, and shows, you know, what that greater complex starts to look like and how it forms. And then you have this other nebula which is nesting in there, you know, as a part of the greater whole. And it's so beautiful to look at that and see how so many different things can come together.
You know, it's a cool one too, to look at visually. I mean, it's if you've got a telescope or, you know, have access to one, definitely go look at this. I mean, it obviously doesn't, well, maybe not obviously, it doesn't look like this to the naked eye. But compared to a lot of other ones in the sky, I mean, this is a bright one. And if you've got good dark skies, there's not much moon out, you don't have a lot of light pollution, you can actually start to see, you know, to my eye, typically I see sort of a greenish, bluish hue to it, and you can see sort of this shape. This, you know, the photography brings out a lot more detail for sure, but it is one of the more impressive objects to look at visually through a telescope. Great time of year for it too.
Yeah, I am. Your image is so beautiful. Actually, no, to me in this orientation, it actually looks like a rose. So when we're talking about the Rosetta Nebula,
yeah,
you know, it really does look like a rose that's opening up. And I actually, not this last spring, but the one before that, used a David Levy comet chaser with the help of another solar system ambassador from the Midwest, was out visiting Arizona, and we took a really beautiful image of the Orion Nebula just on my little Canon EOS camera. You know, I don't have a fancy camera for astrophotography, and there were tons of blues. You know, all of that blue on the outer edges of the nebula were coming through. And it was just really spectacular to see all of that and kind of start to understand the types of gases and elements that exist in that space.
Yeah, no doubt. I mean, you know, this was taken with my astronomy camera, but I have imaged Orion with just a DSLR, you know, attached to my telescope. Now, you know, you need to have an equatorial mount. You need to know how to use the DSLR well and how to stack images and process and all that. But you know, a lot of the images that we're showing tonight, some are hard with a DSLR, but many of them you can get good images. I mean, you can get good images. Someone brought up the Andromeda galaxy, like when it's going to collide with with our galaxy. You can get great images of Andromeda with a DSLR, and a lot of the things we're showing tonight, you can get good images.
Yeah.
Horsehead,
oh no, you know, my
Horsehead.
image was beautiful. All it took was, you know, it was an f8 telescope and a Botnov mask.
There you go. There you go.
You know, and that's it.
Yeah.
The question was, where is this related in the constellation Orion?
I can share. Am I? I am sharing. Yeah. So, do I still have Stellarium open? Sure. So, this is Stellarium. This is a view of Orion. So, you know,
do not see your Stellarium just yet.
You can't see it? Oh, you know why? Because I'm just sharing the PixInsight screen. Stand by 1 second. There we go. This will do it. Okay, sorry about that. So I assume you can see it now. But this is Orion in the sky. Of course, the belt instantly recognizable to most folks. You know, he's got his shield out here. Hanging down here is his sword. And you know, if you're in an area where you've got reasonably dark skies, when there's, you know, not a lot of light pollution, not much moon, you can actually see naked eye this sort of fuzzy area. But this is where you can see, if we zoom in, that's Stellarium's version of Orion. You can see this sort of fuzzy area naked eye, but that's where you look. Just kind of come down from the belt at this angle, come down into the sword right in here, and that's where you find it.
Thank you so much, Brian,
Sure.
for showing that to us. So everybody, I just want to thank you so much for joining us tonight. And that was our last object of the evening. If anyone has any last questions for any of our star presenters tonight, please go ahead and take a couple of seconds to enter them in to the YouTube chat, and we'll go ahead and try to answer them before the end of our show here. And then we'll say goodnight to you. And thank you again so much for coming. We've got a great conversation going on in that chat right now. With people helping everyone to figure out how to step outside and find the Orion Nebula or to find the constellation Orion. So thank you so much for everyone who is helping out in that conversation. Eric Hoyne, you have been amazing this evening. It's nice to make your acquaintance. So you're already acquainted with Frank, and now you've made a bunch of new friends tonight. Thank you so much. And everyone, thank you so much again for coming, and we will see you next month. So make sure that you follow all of our partners on Facebook. You can follow Fred Lawrence Whipple Observatory at FL Whipple Observatory on Facebook. I'm not going to try to say the entire name of the Emil Buehler Planetarium. That is EMIL. You can look that up on Facebook. Follow them as well. Follow the Central Florida Astronomical Society. Follow Sonora Astronomical Society. And you'll hear all about upcoming star parties through the event sections on Facebook. You can also typically follow Emil Buehler Planetarium through their website, and any of us usually on Instagram as well. So thank you again so much for coming, and we'll see you next time.